Okay, today we're here with number 21 on practice test number 4. This is a bit of a trickier looking algebra problem. It gives us the following expression and essentially asks us to multiply it out and get a result in the ax to the power of b format. Okay, so let's go ahead and get this started. This is a little bit of a tricky one, so I wrote out some rules that are kind of necessary to make this flow easier. But let's go ahead and get this started, and then you can see how I use them. The first thing I'm going to do is I am going to separate the 6 from the rest of the product here. Essentially, I'm going to treat it as its own thing. So let's get 5 to the power, sorry, the fifth root of 3 to the 5th and x to the 45th. And now let's go ahead and simplify it out. The first thing we're going to do is we're going to employ the product radical rule. This essentially allows us to take something like AB inside of a square root and multiply it out as A and B individually. So applying that here, we're going to have something that essentially the fifth root of 3 to the 5th times the fifth root of x to the 45th. Okay? And as you probably might know, if you have the fifth root of the fifth power, then using the power rule, it just becomes the product that you have inside. Because if you're looking for the fifth power and the fifth root at the same time, it's really just the base number. So this is just going to be 3 times, and then this second one is going to be x to the 45th divided by 5, or better known as 3 times x to the 9th. And you might look at this over here and wonder how we managed to move the fifth root to interact with the exponent of the base. And the way we did that is through something known as the power rule. We briefly mentioned it before, but because we're looking for the fifth root of the 45th power of x, this then just can just be rewritten as this. You take out the root and you essentially just treat it as an exponent where you're just dividing integers like you would normally. So then at the end of everything, we have 3x to the 9th. And then just for good measure, we have 6 because we're bringing it back from here, right? So we're left with 18x to the 9th, okay? So that's our first one. That's the difficult looking one. Now let's tackle the second one, okay? So we have the 8th power of 2 to the 8th multiplied by x. Okay, and the first thing we're going to do is we're familiar with this already. Same step as above. We're going to separate everything inside. So it's then going to become 8 to the power 2/8 times the 8th root power of x. And all this is really going to equal to is same thing as before, as we saw above here. This became 3. This now becomes 2. And then the second part, remember, we're going to do the same thing we did here. Remove it from the exponent. 1 divided by 8. Because remember, if there's no exponent, then it's essentially a 1, an invisible 1. So all we're doing is taking out the root and dividing 1 by the root, which is 8. So we're just left with 2x to the power of 1/8, right? So all that's left to do is to multiply these terms together. So we have 18x to the 9th times 2x to the 8th, which is equal to, as you can probably imagine, 36. And when you're multiplying exponents together that have the same base, what do? You add them together. So we have to convert the 9 into something with a denominator of 8. So this will be 72 plus 1, 73 over 8. Let me just write this so it's a little bit more clear. Yep, 73 over 8, because all we're doing is multiplying 9 and 8 together, that's 72. And then we're adding one more, because when you multiply things that have the same base, essentially, you add their exponents together, in this case 9 and 1/8. But you need to put it in the form of with 8 as a denominator. So you turn it into 72 over 8. You turn 9 essentially into 72 over 8, right? And then you add one more. And then, so now let's remember back to what the problem is asking. The problem wants ax to the power of b. So what do we have here? We have 36x. Sorry, I forgot to throw that in there. That part remains unchanged. We have 36x to the power of 73 of 8. So all we have to do at this point is add 36 plus 73 over 8, which is a little bit over 9. And we get 45.12, somewhere in the realm of 45.12. I think it's 45.125. You do this with a calculator to get the precise number, but I believe it comes out to 45.125 as the value of a and b added together, because remember we're looking for something in the format of axb. So we're looking to add this number and this number together, which in our case are 36 and 73 over 8.